turn my audio off here. I just want to see if this works. Well, I thought that this would automatically switch, but oh. Here, let's see if I can duplicate. Call it PC Creative Zoomed. I wonder if let me see if I can add like a what's up, man? I was trying to I'm trying to, let's see, I want to capture only a section. How do I do that? I only want to capture a section of the window. Well, that's not it. I thought it was window capture or something. Display capture? No, that's the entire display. Why is this such a pain in the butt? How do I capture it? I thought like OBS used to have this. This is so stupid. Oh, you do everything by filters now. Okay, never mind. So we'll do filters. We'll add a crop filter. That's right. Okay. We'll see. We'll do 33? No. 25? No. It's like 800? 500, 300, 400. It's like 375. Then like 100, maybe like 75. Perfect. And then bottom like we're gonna see how if this works or not. This thing's cool. And I figured I'd go ahead and do it on here because why not? So we're gonna see how this works. Well, what the heck, man? Why did it add? That's ridiculous. It shares filters? 375. Man, that's weird. Okay, so it shares filters, which is weird. No, I can't because I could sleep through a I could sleep through a war. Ask my wife. She'll tell you. That's weird. That is insanely expensive. All right, hold on. So let's apply a crop. And if I remember this, it's 375. Whoops. 375, 75, and then 250, 260. See if I can scale this to fit the screen. Good. All right, now let's try a little trick. I don't know why there is such a lag there. Yeah, so what I wanted to do though is try this automatic scene switcher just to see how this works. So like basically if I'm up here and supposedly when I move my cursor in here, oh wait. Yeah, it's supposed to switch, but it's not. Oh, here we go. The only thing is, it's switching like that correctly, but it's it's not a. That is definitely not a. PC switching PC created. Maybe we can just use a cut. Yeah, it doesn't make a whole lot of sense to me why that's so slow. Like, I wish it would be like a smooth transition. I guess it's because it's the same. It's because it's the same scene. It's funny. It's fighting me right now because it wants me to. It would be cool if you could like edit. Anyway, I'm not gonna mess with it much more. But I was really hoping that it could smoothly transition and not like be so jerky. You know what I mean? Fight back. I wonder what if I like did like fade transition and made it last like 1000 milliseconds. That's hardly. Hold on. Let me see if I can. Let's use fade. Using fade. Okay, let's try this. That's hardly a fade. Anyway, I think the reason why it's a problem is because it's using the same source. All right, man. Like that would get exceptionally annoying if I just kept going in and out of that. I wish you could like add filters. Because that's what I need is the ability to add a filter. Yeah, so you can't add filters. Yeah, I just decided to look at this morning because I just wanted it to. Because it matters. Like when you're doing stuff, you want it to like kind of zoom in. Let me actually see if I can add a new slide. Do like studio mode or whatever. Anyway, I really just wanted it to be nicer and a better experience because I was watching it back and it just seemed like seemed like it could just be a little bit more clear. At least that's what I was hoping for. But it's really odd. Like you can add these filters and stuff. I need to turn this off. That's why. Anyway, actually, you know what? Let's try this. Let's do a window capture. This actually might work. Hey, 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 hey. Cool. Um, I think it could possibly be annoying, but we're gonna see. So yeah, so we'll see how it works out, but essentially having something like this. And if I back out, it's going to go out here. All right, we'll see how this goes. And if it's super annoying, then I'll turn it off. I'm going to try to make it fast. See, like 250 milliseconds. If I just do a regular cut. It's pretty good. No, so basically when I mouse over this area, it's gonna switch. Although what I'm worried about is when I actually run the thing. So I can like run it right here. Let's see what that looks like. Yeah, it's only gonna zoom in. You're actually not gonna be able to see it full screen or whatever. So if I ever wanted to interact with it, it's gonna switch outside the window. I can probably make it so that, let's see, OpenGL. So let's make it so that if, I think we can probably make it so that, okay, let's see what this does. Yeah, it's not, it hates me. Okay, this actually works, but it's gonna be kind of, it's kind of janky. So basically it's gonna switch back and forth, and whenever I run it. Oh, not bad. Not bad. Okay. I like it. Looks good, actually. Okay. Cool. I mean, it like we can probably figure out some of this as it goes, but I mean, in general, this feels a lot better. So I need to get a good idea of what what I'm gonna do today. So yesterday, okay, so let's move some of this stuff. Let's organize some of this junk. Forward last update. Yeah, it is. It's pretty. It is pretty neat. I think you're gonna probably have to end up doing more, with it. I'm not sure that this is gonna be a positive experience or not, but we'll see. Maybe it is. It seems like something that you could get it right with a lot of tweaking and setting up and stuff, but since we just did this in like 10 minutes, it's but the problem was is that if you because I was doing a full display capture, I was like one of them, this guy, if I go back out to the main scene, it's a full display capture. And I couldn't switch from a full display capture to another full display capture, and it like because it like takes time to like buffer, I guess. Yeah, as long as I don't. Yeah, you're right. Okay, that's funny. Um, so I actually, yeah. So what's really going to be annoying though is when I like try to drag windows to show something, or like have a browser. Okay, you know what? I'm gonna add one small other thing. Actually, no, I'm not. No, I'm not. I might just turn this off. Yeah, I do that too probably, and I don't want to find out the hard way. Well, actually, you know what? We'll just leave it. I'll review it later, and if it sucks, then I'll go back and remove it. Um, I do want. Let's see. I can do. PC Dark Souls, PC Creative, Fade. Now let's see if this works. Of course it doesn't. That's the thing is I do that too. So I'm not really sure. The thing that's really that stinks is that it's detecting. It wants to know the full window title and not. You can't just give it like a pattern. So like if I wanted to explain that and I move my mouse in there, it's not gonna do it. What I wish it would do is add and remove filters for me because that would be the best thing. And that way, anytime I move my mouse in here, it'd be fine, but it would just be a zoomed in version, so it would still show my full screen, but it would just be a zoomed in version. That's what's kind of irritating right now, is that it's anyway. Let's see if I can. This is what we're gonna do. I'm gonna move my mouse outside here, and then we can talk about. So we can talk about day 5. So day 3, we're gonna update. We started abstracting a camera, updating the translation of a camera. So we haven't really abstracted the camera, but let's come up with some goals. So today let's talk about So let's talk about camera. We'll see rocks, object, camera, and what else can we talk about? Maybe textures. Yeah, let's do that. Let's talk about cameras and textures today. That'll be good. So off stream, which I don't want to do anything off stream, but so when we ended last week, we had something like we had something that was wrong. Actually, I think I know what it was that we had wrong. We had this part. I think we were just doing this. Oops. So do vec 4 and 0. So we're doing something like this, I think, instead. This is what our cube looked like. And what you're going to notice about this, the weird thing about this is I looked at it, I was like, dang, that looks pretty good. But what the problem here with this is that it looks like the lighting has been applied one time and is rotating. It's not actually keeping the light up here. And as this thing rotates, the light should change. But you can see like this dark spot, it just rotates around with the object. It never changes. That dark spot, it's always in the same spot. And that's not really what we want. What we want is it to be smooth all over. We want it to be smooth everywhere. So I found a couple of issues, and one of the issues was the normals being passed in, but that's one problem that I found. I just found another method that fixed that. But this the issue I think was basically we just needed to move our normal and our vertex positions into model view space, and then we had to normalize everything. And then we could do all our, and then when we run this, it gives us this nice shaded, and you can kind of see the intensity of it as it moves away and towards the light source, which is up here. You can kind of see how, but it's smooth lighted. Like you can tell that it's diffused. And I almost wonder if I zoom out a little bit. So if I set my like translation to like -20, and let's make our cube like -5, -5, -5. Make it 5, 5, 5. Oh, I made it too big. So we'll do 2, 2, 2, 2, 2, 2. Okay, so you can see it. Let's see if I can make this. See if I can make our let's maybe make our light source a little bit brighter. That's actually really bright. So hold on. So maybe divided by 10. Maybe divided by 2. So the interesting thing about this is that you can see the triangles, right? The triangles are actually, let me see if maybe divided by like 3. So this is why like things like the more polygons you have, the smoother it looks. Sort of thing, because The thing is, your graphics card will do a really good job of filling in the gaps, but it's still, you can see how it kind of applies, and it doesn't blend exactly as it should right when it hits that border, those borders. But it's pretty damn close, it's for sure. Yes, everything should be on GitHub right now. Do you need a link? Let me link it for you. Yeah, I'm doing. Sometimes I've noticed that I've forgotten to update from the stream before, but I always try to. So we haven't made it very far, but all of this stuff should be on. And I wonder if I should. I wonder if my packages config has. It doesn't. I think I need to include. I think I need. Oh, maybe no, I don't, because I've. Well. Yeah, I don't need to add it, I don't believe, because OpenGL and OpenGL platform are, I believe, in that. Okay, good. Yeah. Okay, cool. Never mind. I was making sure that I had the libraries committed that I'm using, and that way it's not super confusing. Okay, so so a couple things that we have here, and we're gonna try our best to separate this stuff. And let me actually, I'm going to change this back to like 20. I'm going to change this back to like 10. I need to change the position. Oh, let's see. That's weird. Okay, -1, -1, -1, and 1. 1, 1. Since I moved away, it's interesting though. Why is it dependent on? Should it only be dependent on the? Interesting. I don't think. So I just noticed something, and what I noticed was that when I zoomed, just that I don't want to be met with any surprises, and I'm not 100% sure of the .NET Core compatibility yet. I also don't know if the libraries that I'm using are compatible with .NET Core or not. Plus, .NET Core is a complete disaster right now. We'll see. I know a lot of people are making a push to move things to .NET Core. I think it's probably very close to being ready. And so when that happens, yeah, we can move to .NET Core. I'll do my best to stay in .NET Core compatibility, and not completely jump ship and just go .NET Framework. But we can discuss this, because I have no problem making it .NET Core compatible, but I just I'd rather not deal with extra language or target platform headaches right now. And we can kind of hopefully this stuff isn't, we're not gonna use anything specific to .NET Framework, but I do know that the guy who wrote this OpenGL platform had mentioned that some of the things were not compatible with .NET Core, and that he was working on a port. So we'll see. I'll check in with that library every now and then, see what they've done. Okay, so all right. So one of the things, this may be the default, but I added also some of this stuff, which is these are basically configuration options that are applied globally, and you can change these things at runtime. But right now, we want a multi-sample, which is like anti-aliasing basically. We want less than or equal to depth test. It's actually one of the cheaper depth test functions. The biggest problems that you run into with graphics card, and there's undoubtedly you've seen this. I can actually point out in Pokemon Go, sometimes where the road is above the ground and you kind of rotate your camera a little bit, you can see part of the road like seep into the ground. And the reason why is because the graphics card is trying to process things at a distance and is trying to map things to the 3D space, and those things are actually occupying the same space, and it has to pick which one shows up first. It doesn't have any sort of like ability to measure depth. And so you provide it here. This is how I want you to measure depth. That's the basis of it. And then the other thing is face culling. And basically this is when you have a cube, you can see visibles like 6 sides, right? But OpenGL will try to render not only the sides that you see, but also the sides that you don't see, like that are on the inside of the cube. And so we want to tell it that we only want it to render the front face. We don't want it to try to render the back face. That's the other thing. So rendering, not culling anything or disabling culling is probably useful when you have like walls, like when you have like single quad walls. But I don't think I've seen that since like Wolfenstein 3D. Okay, so let's talk about this camera today, because the camera is a little bit different. Oh, no. Sorry. I spotted a bug here. So our bug that I saw was basically when I'm at this distance and you're barely going to be able to see it, but there's the cube in and out. But you can notice it's a lot darker. But if I move my camera position in, like if I zoom in a little bit further, well, then you don't see anything.
Come on, kill
Why not?
Me,
Why don't you? Oh, that's light position.
No, kill me.
Thank you for the follow. Appreciate it. It conserves memory, but it also prevents any sort of weird render artifacts from showing up. Sorry. So translation is our camera position. So if we zoom in, look, all of a sudden the thing's bright again. So it looks like the actual brightness of this thing, and maybe that's a cool effect, is that when you're further away, but really our light source doesn't change position. So the thing should never actually change brightness based on the position of the camera. So the reason why I think this is because we're applying the view matrix and the model matrix. And really what we want is we just want the model matrix to be applied here. Times view matrix times vertex t. Okay. So I believe, are we using MV anywhere else? No. So this should create this. No, and it doesn't, of course. Damn it. To hell. Actually, yes, it does. This is what we want, but I think we just want to dim down the lights a little bit. Does that seem right? Let's slow. I want to slow this down because I want to pay attention to what's going on. That doesn't seem right. $0005. This will be very slow, but actually, and let's slow down the rotation too. Light source is up here. We should be, in my opinion, I mean, we should be seeing, it's going too low. Hold on. So -2, +2. Okay. See that, why the edges? We're seeing the edges. So what we want is, this isn't, we're not necessarily seeing shadows, but we're seeing kind of the way that it's basically the graphics card is looking at each individual vertex position and judging but the edges are showing up as ones. And that's what I guess that's legit diffuse lighting, but I'm not sure why the edges aren't blending. I'm just reading. I've Googled. Okay, so we are doing this right. We're only supposed to use the model, but normal, what is normal? Why? So let's see. Normalize normal. So I wonder if what we're supposed to do here is not actually apply. Let's see, normalize in, nope, it should be vec4 in normal 0. So what I'm, wait, does that need to be a 1? Yeah, no, see, that's wrong. This is like the static coloring that I was talking about earlier. It like only applies it once. It doesn't actually apply it over and over. What happens if you do this? Nothing. Good. Just making sure. At certain points, the transition looks good, but what I'm trying to really figure out is why it's so, why are there edges? I don't think you're supposed to be able to see, I mean, like, it's supposed to be a smooth transition. You're not supposed to be able to see edges like that. It's supposed to be smooth. I wonder if... What's up, man? Why this has got me so tripped up. Because this seems right. The model matrix is offsetting it. We don't care about where it is relative to the eye. It should only be relative to model location. But why do we have to apply this normal? Why do we apply the normal to the... Oh, I guess that makes sense because the normals have to rotate as well, but the projection shouldn't matter. Or the view shouldn't matter. So that's right. That's right. Light position. None of this should matter relative to where you're standing. What does sputtered mean? It doesn't, Bo. That is unimportant. It's unimportant. It's if it's not it's supported because it's running. I've changed. Look, I've changed it just for you to 330 core, geofrag core. Like, it's okay. If it's not supported, then we'll change it to the to a different output. It's fine. It's fine. Frag color. I'll actually tell you when it's supported. If it's not, we'll change it. It'll be okay. OpenGL ES2, geofrag data, out, bind frag locations that only have one output. On OpenGL 3.0 and 3.2, assign a named fragment shader output, associating the named output with a numbered buffered. 3 and 4, assign a named fragment shader output, associating the name output with the number buffer by using layout qualifier. let's see. Let's open this OpenGL solution. You're not going to be able to see it, I don't think, because of the scene switching. But hold on, and I will bind frag data location. Okay, find drag location. Find all references. Doesn't look like we're actually using it, so it's probably okay. Yeah, it doesn't matter. For right now, it's fine. It looks like it's working, so I'm not too concerned about it right now. But yeah, really what you do is you can bind an output buffer, and you just tell OpenGL which one to use before it, and then you would just use it in here. It's not even it's not that big a deal. So what I really need to figure out here is let's do this. Let's do out vec3 and normal, and let's do out vec3. Give me a second. Oh, man. And then light position. Sounds like we were gonna actually need to do lighting position inside the. What's really. Actually, yeah, here's what we're gonna do. I need where are the programs? Oh, here it is. Basic lighting, and then this one, ambient. So light position, light color, object color. Okay, so let's try this. So a position. So we're gonna set, this is gonna be a post, and this is a normal. It's gonna be equal to those things. We're gonna take this stuff. Actually, we don't need this or this. We have color, light position, and these need to be inputs. In, and then we need to actually take this stuff although I'm a bit confused here because it still seems like the normal to these objects should be relative to where they are in world space. So let's normalize a normal, a post, a post. Light intensity. cosine theta, frag color. Yeah, I thought that was going to fail, but why does it fail? And why does it always switch to that line of code? Let's see. So in and out match up here. In position, in normal. View matrix, light position, light color. Normalize. In. 0, 0. Oh, this is why. Float and float. Define those things. Yeah, this is all, that was Bo's suggestion to do it, but I need to, there are some things that it needs fixing. Needs fixing. So it's not working. So let's figure out why. Yep, still not working. So why? Why are you broken, thing? Model matrix, view matrix, projection matrix. Those are all good. In normal, in position. A post, A normal. Maybe this? Very curious indeed. Oh, this is why. This is why. So we'll do this, and then vec4 norm, and then this is what the problem is. So a post, this is actually going to be, this just needs to be posts. This needs to be, so what happened was it was a vec4 and it was expecting a vec3. So here we do x, y, z, and that changes it into a vec3, and then a normal is equal to norm.xyz. So let's just make sure this works. Okay, good. It does. We get something. Now let's add back our calculations. All right, here we go. That's what I'm talking about. All right, so let's. I knew better than this, but I did it anyway. So what I will explain. Give me 1 second. Let's get the. That's a little too fast. I think I kind of like the 0, 1. I like this. I like the small rotations. No, I don't. Can we get it a little bit faster, please? I should just make it so that up arrows and down arrows change the speed. So it's kind of neat. So this is what we want. This is what I've been looking for this entire time. See how it's smooth. The lighting is all correct, but it's smooth. Like there's no like jagged edges between the lights. And the reason why is because we were doing this calculation for the lighting, we were doing it in the vertex shader, and that's a no-no. You should always do any sort of lighting calculations in the fragment shader. I mean, that's what it's for. But the reason also why is because the fragment shader is applied to the tessellation effect. So like basically as the graphics card fills in the spaces between vertices, it's basically going to be tessellating across, and it's going to be calling the fragment shader each time. And so you get a more detailed, precise plane. No, I just have a general light source that has a intensity effect based on the distance. This is just diffuse lighting. And so the light's up here, and so the farther away it gets, the more it gets lit, whatever. And we can scale that intensity however we want to, 30, whatever. That's what I had it set on 30, so that it goes in and out of the light source. So the further away from the light that it gets, the darker it gets. Although that little artifact right there is a little strange at the top. I wonder if that's due to this. Let's clamp it instead of max and see. Yeah, it's still giving us the same effect. Well, that's something to look into for sure, because it's odd that as it's going out, there's the single brightest spot right there in the middle. More it gets lit. Yes. Just trying to figure out where let me look at one more thing. So if we don't actually use the light intensity here, which we can just say that say that light intensity is like 0.1. Oh, let's give it a little bit more than that. Let's say like 0.5 maybe. So there is that very odd, wait, why is it still doing that? That light intensity, what? Now I'm really confused. Okay, so really we can do something like this. So let's try this. So instead of, we'll do float ambient, and we'll just say our ambient intensity equals 0.1 F, and then we'll say vec3 ambient color is equal to ambient intensity times color. Oh, that can be, our light color here is going to be 1, 1, 1. If you haven't figured that out yet, it's just white light. And let's go ahead and just do this. We'll do vec3 diffuse equals cosine theta times, again, well, I guess we'll do this. This will be our light. Actually, let's do this. Vec3 light color equals vec3, and we're just going to do 1, 1, 1 here. So that way we can light color. Let's get rid of this. Light color. And then the actual color, no, this is vec3. This needs to be, we'll just call it frag color. Frag color is going to be ambient plus diffuse times the object color. And this should give us something similar. All right, but okay. So now you have this like base ambient light that you can still see the object, but it's coming in and out of light. Although it is very curious to me this little, I guess that's normal. I guess it's just as it's going out, I don't know. That's an interesting little artifact. But at this point, at least you get like a base amount of color regardless. Just making sure everything I'm passing in here is kosher. I don't think that I have to normalize this, but let's do it. Yeah, same effect. Okay, that's probably already normalized. Anyway, okay, so we got this. So let's just try to, I guess, move on here. So like the other thing we can do here is we could make this like a nice purple. Oh, that's, yeah, I guess. So like we can alter this color of this thing. And if we wanted to do something fancy, we could do something like well, I was gonna fade it around, but let's not worry about that right now. We can do that later. That doesn't really even help our calls here. Okay, so let's talk about this for a second. So let's group everything based on, let's just kind of visualize what we're going to do here. So like this stuff is, just initialization, window options. These things are more runtime. So is the depth function, but we'll just keep them. We'll keep them here for now. This is going to be kind of camera renderer right here. Well, insert the most worthless key ever. Camera and renderer, and that's going to include this, and this guy. Oh, yeah, the one thing that I did want to test here is we wanted to make sure, remember, that if our distance changes, so now you can see, even though our distance with the camera changes, the lighting still stays the same. Before, we had our distance of the camera somehow affecting, it was somehow affecting where we, how the lighting displayed, which is not what we want. So this stuff right here is all camera. This is camera, kind of. We'll create this up here. This will be, create this. This is object. We'll just call this scene. Let's put this up here. So all I'm doing right now is just kind of getting kind of a visual mock-up of our design. Just trying to take this like ridiculous like demo code that we have and actually apply some meaning to it. So this will be, actually this is going to go into this. This is actually this projection needs to be above this, and then let's just make sure that this. Don't think, but I could be completely wrong here. I wonder if, yeah, sucks. Okay, so when we actually create the cube geometry, the shader, I think at the least the shader has to be created. So let's try putting it here, and I think this will be fine. Yeah. Well, that actually makes a little bit more sense. I was a little bit so technically this is more scene. This is more scene. Okay. Anyway, so we can group this effectively. I'm just gonna put the geometry stuff back down there where it was. It's kind of our odd updates. So let's just do this like primitive void, update objects, or update scene. And then we'll call update scene from here. So this should have the same similar effect. I'm just going to make sure each step so that I'm not absolutely breaking something and don't know later on. And then we'll just call that, we'll say this is like scene dispose. And all I'm doing is kind of just grouping and organizing the stuff. And this will it just makes it easier to start using building blocks. So scene dispose, update scene. Actually, this should be dispose scene. Okay. So the thing is like, so the shader variable right here is the shader program, and it's what we feed the text from here. So like ultimately what we're going to want with our voxel engine is we're going to want like a fairly generic shader that is able to take input and apply lighting and textures and stuff like that. So we're going to end up with something like this. That's kind of the point. I guess the point of all of this is to kind of understand that when we get to a point later where we're just rendering cubes, we're going to want a fairly generic shader. So let's talk about a few things. Let's talk about, so the projection based variables are basically it's the aspect ratio. I guess we could change if we wanted to, but let's just keep the aspect ratio for now. So let's go into this render and let's just create so I'm trying to think, what do we want? I'm trying to think how we should define this stuff. I don't want to move too quickly. So let's actually just move into this camera. So we'll have this. We can come back and do this later, but let's make the camera, or we can come back and refine this later. But let's make. We want our camera to extend this rocks object. We want it to retain this stuff. So I wonder if do we need to update transform? Okay, we can keep this like this for now, but I think we can do a lot of optimization to this class. But let's so our rocks object can accept position and rotation. So the question is, do we want it to? Give me a second. Somewhat drawing a blank here. What I want to do. So I'm just going to refer to this, to my little prototype here. So let's do this. This is what I was trying to consider what I was doing. So let's just make a viewport, which is basically, I think, just going to be Yeah. So let's just, we can probably make this a struct, but let's see. We'll just call it view. And so C# has value types and reference types, just like C++ and C. Value types basically are allocated on the stack, which means they are volatile pretty much. Whenever, if they're created in whatever scope they're created in, when the scope dies, they die. And so when you use them to call methods, they copy. So they can be kind of expensive, but they're also super cheap because they're on the stack and they're in and out. And so they're actually can be quick, but if you're doing a lot of copying around, they can be really expensive. So you have to pick kind of how you want to use these things, and you want to use them appropriately. In our case, we're not going to be slamming views around, and since it's kind of a lightweight object, we're just going to make it a struct, which when you make it a struct, it makes it a value object. Now, structs can be promoted to reference types if you, like if I included as a property on here a reference type, sometimes view can get promoted. It's kind of up to the runtime to do a lot of this stuff. So what we want our view, we want our public view to be we have int. I think we used ints. So let's just use. It really should be uints, but we'll stick with GL construct. So width and int height. And let's do some public properties. Public int width. Get private set. I'm gonna keep them read only for now. For let's see, use to determine aspect ratio. This is going to be a very, very, very basic object you're going to find. So I kind of feel like maybe we could abstract out just a little bit more. Maybe it depends on if we are going to use any sort of rectangle later. Let me see what rect. No, not really. Technically, we could also give this view a position in two. So this is a two-dimensional. This is a two-dimensional object. This is basically a rectangle. Our view is basically a rectangle. It's got an X, Y, and it's got a width and a height. We aren't gonna change position yet. We may later. We'll come back and change it if we have to. So we can also add some helpers here. So like we'll do float, and we'll say aspect ratio, and then we'll add a getter, and we'll just have it return float width divided by height. What's up, Colt? How's it going, man? Ration ratio, aspect ratio. Sweet. Sleeping in. So I have this, we'll call it view. We'll call it viewport. We'll call it viewport. We'll call it viewport. No defaults. So let's see. We'll have our viewport. viewport. And we'll just create it right here. Viewport equals new viewport and width, height. And viewport. Actually, what we can do, even better, let's do this, create window. Let's see, since we're breaking everything up, let's do void create window, and we'll do OpenGL, create, I think it's window dot create window. And what do we call this? OpenGL, and then viewport dot width, viewport dot height. Bam. No. No, what is that? So we create our viewport, and then for our aspect ratio, we can do this guy. So this is going to be important in a little bit, and we'll do aspect ratio. This should give us the same result, and it doesn't. Of course it doesn't. Why the fuck not? I'm going to right line this bitch. Aspect ratio, because I think that's what's wrong. I think it's something to do with the way that I casted it. Actually, no, it's not. Interesting. So what the hell did I change? What did I change here? What did I break? How did I do this? How did I break it? That's how I broke it. You know what? We are gonna make you know what? We are gonna do this real fast. So our viewport, we're gonna give it X and a Y. And then public Y. This will be the easy one, and then this one will be the int X, int Y, int width, int height. X equals X, Y equals Y, width equals width, and height equals height. And we'll remove this. And this will be this 0, 0 width height. Okay, so what this little guy is gonna we'll just keep that on the same line. This is just gonna call this one with 0, 0 as a default. Okay. It's basically full 3D version of that where you generate UV coordinates according to 3 plane calculations. Yes, but what context is this? I'm trying to think. I have heard of something like this, but I've never heard it by the formal name. Give me a second. Let me pull up this time over here so I can see what it is. West Coast. since I'm on the East Coast here, West Coast can be tough to follow. Okay. 9:20. So we got a little bit. Seems like it could work, I think. Seems legitimate. Okay, so we'll just, let's see, X coordinate of the viewport. We'll add some very, very basic comments here just to keep things documented. Let's see, we'll do Y coordinate, width of the viewport and height of the viewport and the aspect ratio of the viewport. Okay. Easy enough, right? Okay. So, let's see, we'll have our little public void update viewport, update view of viewport or whatever. Actually, you know, now that I'm, no, never mind. So, update viewport. And this guy will just use our values from here. We'll do GL viewport. And then we're going to pass our viewport values. Viewport.x, viewport.y. Brilliant. Okay. Easy enough. And then let's do like clear render. Or clear window. Let's clear window. Or maybe just clear, actually. Okay. Easy money. Yeah. Yeah, you. We'll just make this guy called like is basically we just want to how do we elapsed frame time. Wow. Why don't I just spell confifi? Elapsed frame is elapsed frame confifi. Continue. So, we're just kind of separating again. We're just separating everything out so that we have nice little modular pieces, little methods, functions that we can. I'm not going that deep into this. Kafifi frame. Okay, so let's start piecing some of this out. So we have our camera. Now that we've created our viewport, let's So technically, all right, if we need to make these interchangeable next time, we will. For our camera, we can probably, so at the minimum what we need is, and actually let's give this rocks object, let's give it a new, let's give it something to identify it with. And we'll make it protected in terms of writing. And let's give it a name. And let's let you pass a name to it in case we want to be able to look up things later by name. We can either do it by mapping or whatever. So let's say string name, and we're going to do name equals name. And let's see, we'll do string name. I'm not really super keen on any of this. This is, we'll just start it at 1. Dude, this is a great article. Oh, NVIDIA. God, I love their page. Or their pages. Are these guests? Or are these actual NVIDIA people? Because this is insanely cool. Are these the gems? Yes, GPU gems. God, I love those. They are so cool. Sometimes they're way outside of my reach of what so we'll just do this real fast. Private string new default name, and it's going to be static. And basically what we want is we need to, let's see, we want a string format, return string format. Wow. Things are just opening up. String format. We'll just say rocks object with this, and we'll do a interlocked increment ref IDs. Easy. Easy. So the interlocked increment, just to be clear here, we are planning on using some sort of multi-threaded approach, and whenever you have shared memory, you risk multiple threads trying to concurrently modify the same memory. So we need to use certain constructs to prevent that from happening. It's basically like a way of saying, okay, you can, it's pretty much like a traffic stop. It's if a bunch of things are trying to access one thing, it's a guy that says, okay, hold on, you first. And then once you had your turn, then the next person can go and the next person can go and that sort of thing. So that's what we have here. This is an atomic increment, basically. So it allows you to increment a 64-bit value atomically. It just means without anything else being able to modify it. So if we pass in an empty constructor, we're going to want to do a new default name. If we pass in a name, yes, I would like to know. If we pass in a name, then we do vector 3.0. And then quaternion.0. And then I like how it puts it up on that line. I actually like these next, to be clear. And then vector position only is just going to be, we're going to do new default name. So what we're just going to do is we're just giving these objects, these random objects, a name if we don't supply one. So right now, basically, default constructor, named constructor, we should do this, and then we should probably have another one that is public rocks object string name vector 3 position. And this will do the name, position, and then quaternion 0. That's it. Anyway, so if you don't supply a name, it will create one for you. And if you do supply a name, it will use that name, but it doesn't go for uniqueness. It will only go for the incremented value if you increment it. Sweet, Bo. Yeah, so I'll be honest, the interlocked static, it supplies basically all the atomic multiple constructors. Nice. Yeah. So we can get into the atomic stuff. The one thing, if anyone is curious who's listening now that is curious about interlocked or atomic structures, but they're used to something else, I'm going to try to navigate this without crossing my mouse threshold, because it will switch to my code window. But I have in the same repo, it's going to switch, sorry. In the same repo as, actually, I can turn this off real fast. Give me a second so we can check this out. Okay, so in the same repo, basically, if you go to my GitHub page, the same one we have rocks in, there are a couple little projects that you might also be interested in. One is this Java Ray. It's a ray tracer in Java, and it doesn't use any sort of OpenGL or anything. It's basically just modifying screen pixel data. So it's very slow. And then I also have this CSharp Atomic class a long time ago, before .NET Core and before like backports of the task parallel library or whatever for C#. If you used Unity, you were restricted to Mono version 3.5, which doesn't have some of the thread support that the higher versions of .NET has. And so I had written a thread local, a countdown latch, some locking that resembles Java locking, reentrant, and lock conditions. And also atomic wrappers, so like atomic boolean and stuff like that, where you can, which all uses interlocked exchange and stuff on the inside. But atomic long, all these atomic wrappers that basically just are, it's not always obvious to, at least for me. I was a Java programmer before I was a CSharp programmer, and so it helped me learn a lot of the concurrent models in CSharp if I could relate to the APIs. And so it was part of a port, and it's also compatible. It works in Unity. So if you're interested, you can go there, check it out. Right now, we don't really have any direct use for it. So since we're using a higher version of .NET and we're not using Unity, it doesn't really matter. We can use all the normal stuff. Okay, so back in here. So we have this little namer, and I apologize that I haven't gone through and commented all this stuff. I might comment a lot of this stuff off camera before I commit to the repo, just to have some sort of clear. All this is doing is when we say give us a new default name, we're incrementing this variable by 1. It'll be 1, 2, 3, 4, 5, whatever, and it's going to prepend a rocks object, and then so rocks object dash and then whatever the number. So it's just going to give us an increment of that every time. And that's only if we don't pass a name ourselves. If we pass a name ourselves, it'll use that name. So our camera object. And the reason why I wanted to add that name is because I feel like we should take a look. It just depends on what you're familiar with. If you're familiar with like Java or C++ or anything like that, where you use kind of these so for atomic access, like you use an atomic boolean or atomic long or atomic int. They're actual types that you use, versus like C# wants you to use an interlocked on a primitive, and it's just two different ways of looking at it. No, it's my dog. It's my dog. Let's see if I can see over there. You see him? I'm actually curious. Yeah, there he is. Rolling around on the ground, making noises. Jerk. What his problem is, man. He's being annoying. Hey! Hey, I'm watching you. Quit making those noises. He's like scratching his face. The GitHub repo is, let me paste it. There you go. Okay, and rocks is the one that we're looking at. Anyway, so here we go. Back to camera. We will probably eventually provide a way to name these. That's just why I added that the naming to the. Actually, you know what? Okay, no, I'm not going to do that. Let's kind of see if we can force a name here. So string name, and then I think we want to do like we want a viewport, and then we want a float field FOV, and which is going to be field of view, and we want a float near Z and a float far Z. And we can probably give these, and here's another way to do constructors, though, in C#, is instead of having different variations of, you can give them default values as long as they're at the end of the parameter list. So like for this, the default values for all of this are like going to be like, what do we have? 0.1 F for close. And then what do we have in our main class? Do we have like, here, I need to move all this stuff anyway. So private float. Field of view. Private float. We don't, since we're storing viewpoint, we don't actually need aspect ratio, but we do need near Z and private float far Z. And these are going to be, and then 1000. So 0.1 and 1000. Those are going to be our defaults. Hey, let me get him. Come on. Come on. You've overstayed your welcome. Come on. Out. I have like industrial carpet in here, and they like rolling around on it and scratching their backs and stuff and moaning and groaning like they were doing. We're just gonna do a little bit of formatting here just to make it clear what's going on. So this is actually, we need it to call the base constructor. And this is always the tricky part of this. So we want this to call the base constructor, and we want it to call it with the name, and that's it, because we're not using anything else. So we'll call the base constructor with the name. This is not sitting right with me. Why is this not sitting right with me? This weird syntax. I don't like it. I don't like it. Anyway, that's what I'll do for now. I'm not a fan, by the way, of the way this looks, but I think it makes it clear what's going on. So the base, you call base for the super object, and you call this for the current object, to forward things to constructors. So this is actually going to apply the name constructor for Rock's object to this object, to everything underneath this. And then we're going to do viewport equals viewport. And we're going to do field of view equals FOV. Near Z equals near Z, and far Z equals far Z. And maybe eventually we'll make these modifiable, so that, and we'll do a similar thing. We'll set a dirty flag and that sort of stuff. For right now, we need a property called, so the view matrix is going to be position and rotation from the super object. Rocks object. What did I want this to do? Update rotation. I think I wanted rotation to actually, okay. Again, I'm not going to mess with this right now because, but we want, what we want is a private, matrix 4 projection. And we can probably go ahead. It's really interesting since we're going to keep these variables for now, but technically we don't need them because we're just going to create this one time. And so field of view, and then we're going to do viewport.aspect ratio, and then z near z, far z, and this is going to create our. It's going to create our. I wish that it would automatically snap those things based on. So I'm gonna make this read only because it is, and we're just gonna add a get for it. Public matrix 4 projection. What up? And then so interesting. How do we calculate this guy? Oh, I think that we have a new class that we want to really pay attention to called, let's see, let's see, OpenGL.Frustum. Hey, it's doing just fine before I met you. Drinks too much and that's an issue, but I'm okay. Yeah. So let's see here. So let's see what this API is like here, because I have no idea, to be honest. Let's see. So view for some update Frustum with a clip matrix. Interesting. Oh, there's one overload. Beautiful. Beautiful. What is the clip matrix though? What is that supposed to be? I guess. Okay, so here's all right. Okay then. Okay. So what we can do here is we can do update Frustum, and we're gonna pass it. Not our clip matrix. The clip matrix overload, I'm not sure what it's for, but we're gonna pass it our projection, and we're gonna pass it. It wants your model view, but what we need to give it is the model view for the camera, which is going to be transform. Okay, we're not going to actually be using this yet, but it will be very handy later. So we're just going to go ahead and use it. And we're gonna make it gettable. It's gonna be read only as well, and public custom view get return view custom. Nice. Cheeky, I'm building kind of the basic, or I'm working on the basic building blocks of a Voxel engine. And we're starting at the very bottom. We're kind of working our way through OpenGL, how it works, GLSL. We've written a bunch of demo code that doesn't do a whole lot. And we're just kind of now we're starting to abstract out the different objects and different parts of our architecture that we're going to want to reuse. And so right now we've kind of created like all the general we've created like a view and perspective matrix, and we've made a little cube, and we've applied a model matrix to it. And then we've rendered everything using GLSL and a shader program and whatnot, and now we're trying to kind of piece it all together. And we've applied like rotations, we've translation, all that good stuff. So now we want to take all that demo code and we're kind of starting to organize it in sort of an object-oriented fashion. And we're going to make our way slowly towards voxel creation, terrain generation, that sort of stuff. I hope that answered your question. If you have any more, please let me know. I mean, you can. There's no bad questions here. Yeah, Bo, hit me, bro. Cool. Yeah, man. Thanks for hanging out. Thanks for stopping by. We'll get there. I'm not gonna. So this little cube that we have in the this little cube that we have right here, I'm not actually gonna do anything with this thing. Right. What we're gonna do, what we're gonna do basically is we're going to, in memory, we're gonna create voxels, individual voxels, and we're gonna have some fairly loose rules about the creation. We may just start and say we want to generate all of one type of block, and what we'll end up doing over time is we'll take all these blocks, and there'll be a lot of them like Minecraft-y, place together, and we figure out things like when they're all together, basically the best way to like build the entire mesh for that object and how to attach things to each other geometrically so that when you modify them, things update. Like, so if I change a block, what has to happen in order to like propagate that change? We'll probably do some sort of ambient occlusion lighting, because it's really fairly straightforward to do in a box or a block-based voxel engine. We'll just kind of, once we get to kind of a certain point, we'll just kind of do what anybody wants to do. We'll just go in it whatever direction that you guys want to go. But I think just kind of starting out and just letting me just kind of work through some of the basic stuff, and then once we get to a point where we're like moving, then we can really start going a little bit deeper in the implementation. So we have our projection, we have our view. So just so you, it's clear what this is an object that is capable. If you look at there's basically two methods on it. So the view custom is basically got an update and an intersects. And what's beautiful about this class is that it's a super easy way to determine if what your camera is looking at intersects with anything. So like if I have an object behind me, there's no reason for us to do anything with that object. We don't care what's going on with that object. We definitely don't want to render it. Now, we may care about it in context to like the scene and how things or what things are happening in the background, but we don't want to render it for sure because it's behind us. We can't see it. So the way that we can tell if something's in front of us or behind us is we just pass the bounding box for that object to this little frustum class, and its matrix, its bounding box is basically the exact same as our camera, what our camera can see. So we can determine if something's in our view or not, just by easily calling that little method. It's a super handy function. So I think a few things we want to do. We want to override. Well, I thought we wanted to override. Apparently, I didn't make anything virtual. I forgot about this. This is one of those tricky things. So because we're using an abstract class here, we want to make these things virtual. And basically making it virtual just means it's going to give us the ability to use a big word. Well, I'm not sure. I'm actually not. This is bad that I don't know this. But it's actually, I'm not sure if using virtual is a requirement for polymorphism in CSharp or if it's just a hint at it. I'm pretty sure that you can override. So let's see what we can over. So public override. This will normally give me. So it doesn't show me anything that's non-virtual. And let's see. So public override, protected override is going to let me. Okay. So really what we want here. Wow, it really was serious about giving me, about generating that for me. We only want update. Gosh dog it. We want to update, override, update transform. And when we update our transform, like so, it really actually would be nice if we made these return a Boolean. So we'll make these return a Boolean that basically says, did we update or not? And that will give us the ability to determine in our overrides. And I really want to be clear here because I think it's important. And I think that it's the easiest thing in object-oriented programming to abuse is these giant subclass hierarchies. And if you're just kind of learning and you're figuring out like all this stuff, oh my gosh, it's already. Give me 1 second. Okay, sorry about that. So you're basically yeah, I know. You're basically subclassing. When you're subclassing things, it's really easy. It's really easy to want to always use it because I think one of the bigger misconceptions is that maximizing how much code you share will ultimately make your program better. And there are lots of situations where that is absolutely true. Maintainability wise, absolutely. If you have copies of the same code everywhere, if you want to change any instance of that, you have to change all of them. It becomes like a maintenance nightmare, a flexibility nightmare. However, it's got to be very clear cut. That's my rule. Is it's either clear that something should be overriding something else, or it just doesn't need to override it, or doesn't need to subclass it. And in my opinion, subclassing of this type, this should be abstract. This thing should be completely abstract. You should never be able to instantiate one of these. You should only be able to override it. And I do these things not for my own or just not for like other people's sake. When I'm professionally programming, I don't just I don't just like imply rules like you can never subclass and stuff like that. But for my own sake, like if I'm doing a personal project, I'll make this abstract, and I would make camera in a lot of cases. I would make camera sealed, which means you can't subclass it anymore. It's basically done. And so all that I'm getting out of doing this subclass is that I'm getting this shared code base or this shared object code, and I'm just kind of inheriting it through one subclass. Because what ends up happening, you build these giant subclass structures and things start to be different. And you need to add support for one thing. And what happens is you don't have the freedom to make changes without affecting everything else that uses that subclass. And it becomes a very nasty design problem. And so if ever you're in doubt and you think that you want to maximize shared code, but you're not sure that it's going to be maintainable via subclassing and creating these hierarchies, then my suggestion always is to create an object that is capable of, I guess, attaching. It's the correct design pattern, I believe, is composition or decorators, or it's basically objects that enhance other objects. And you keep the behavior, the enhancement behavior, separate from the object that you're enhancing. So rather than subclass this object and then adding a bunch of stuff that makes it enhanced, you add an object that it will enhance this object, right? And then you find a way to kind of keep them together, or you composite them together. And this sort of design keeps your behaviors and your representation completely different. And I would always suggest using sort of a composite pattern or composition pattern over subclassing. At least if you're going to subclass, keep it one depth minimum or maximum, which it seems silly, but I promise it is absolutely worth it. Nobody wants to go in and debug 3 hierarchies of subclasses. It's miserable. I'm going to look at it in just a minute. So here's what we want to do. So did update. So we're going to update our transform. If it did update, actually, this is what we're going to do. We're going to say, oh, no, never mind. If did update, then we need to update our view frustum. Update frustum. And we're going to do projection and then transform. And then we're going to return did update. So what this does is we're overriding, and this is polymorphic because once anything in Rock's object, if it's a camera and we call update transform, even if we call it from Rock's object, it's actually going to call this one first. And in turn, this one calls the base update transform. So this one will call the one in Rocks object. So the reason why we do this is that we want to make sure that anytime we update our transform on the subclass on the Rocks object, that also we update our view frustum here. And likewise, if we make it right now, the projection doesn't change. And so we don't have to worry about if the projection changes, because we only have to worry about the transform, because we are just setting the projection one time here and that's it. So if we update the transform later, if we want to allow the API to modify these sorts of things and to modify the projection, then we have to allow updating the frustum based on the projection changes as well. Yes. No, I'm much better at this than I am Dark Souls runs. Unfortunately, I would trade for a day to be good at Dark Souls runs. So sad. So let's see. What we want here though is the next thing we want is public matrix. I don't think we definitely don't want, we're not really concerned right now about getting the MVP, which MVP in this case stands for model view projection. Thanks, man. I appreciate it. Here's my hype. Or Klappa. One moment. So let's give this a whirl. Basically, we're not baking any of the matrices in our application yet. So let's do this. Let's try it. Let's just see if this works. My guess is it's not going to, and we're gonna have to come back later and figure it out. But we have a cube, we have a viewport. Let's create a camera and just call it we'll call it main camera. And our main camera, we'll just instantiate it here. Is new camera. We'll call it main camera. We'll pass it the viewport. And actually we'll leave all of that stuff alone for now. And the other thing is, and then what we'll do is we'll set main camera dot position equals new vector. It's not going to let me set that, is it? What do we make this? What do we call it? Main camera dot move to? Yes, move to 2, 5, negative 10. So we're going to move the camera in place. This is what we need to do. We'll add one more quick. Wait, do I have a look at? Yes, I do. I do have a look at. So we will call main camera dot look at. Wow, this is awesome. Wait, what is translation? What was that? Did I just delete that? Oh yeah, that's oh shit. Stupid keys. All right, so that's an eye position, but what we want is we want to main camera dot look at. We just want to look at the position of the cube and our up vector, and then actually we should probably give this a public virtual void look at, and this would be neat. iRocks object, so you can pass a object, or I'll just say obj and vector3 dot or vector3 up. And really and truly, we should be able to calculate our up based on our rotation. But I'm not sure, to be honest. I feel like this should maybe be up. And this shouldn't actually accept. We're going to keep this like this for now. We may change it. So transform equals matrix 4 dot look at, and we're going to do object. Oh, we need to do position object dot position and up. Yeah, it only helps if you haven't done it in a while and you want to refresh, because that's basically what I'm doing now. So we want to look at, so we instead now we can pass our cube. We don't even have to pass the position. We can just pass look at cube and pass it a Y. We don't need the projection matrix anymore. And these are kind of our initial values. So we'll do here, we'll do not cube, we'll do main camera, and we'll do projection. And the view matrix will be main camera dot transform. I think we're changing this every time, so this doesn't even matter. Model matrix. Yeah, this doesn't need to be there. The light position can be there. We will create the light later. And we're getting there. Eventually what we're going to be able to do is pass in a specific shader, and it's going to set the camera values on the shader. But our view matrix is still going to be main camera dot transform. And what we want to also do is, so we're moving the cube, and we're rotating. So, okay, so we're good. Oh, I knew it was going to happen. What's it angry about? Is it the frustum updater? Matrix 4. What's it being called from? Look at? Look at. It's being called from look at. Rod object. Look at. Camera update transform. Let's see what this is. Forward is 1. Position is 0. Up is 1. So that should all be fine. Okay, hold on 1 second. We're going to figure this out. All of this looks fine. Stack Overflow? Really? Did I really just blow out the stack like that? Is this? Are we serious here? All of this looks fine. Did I really just did I blow out the stack right here? I don't see how this is possible because I mean to look at it's right. I really think that I just blew out the stack. Are there stack size settings? Is this gonna give me? You are getting a Stack Overflow because of this section. Is it? This makes no sense to me. I am completely blowing out the stack just from creating. But normally you get this from. What doesn't make sense is normally you get this from like. You would see like 100 recursive calls. Oh, shit balls. You do see 100 recursive calls. Well, what is calling update transform over and over? This is insane to me. Okay, wait a second. So update transform true. Wow. Wow, wow, wow. So I had a feeling when I wrote that code that it was going to come back and haunt me. And it did. So we don't want to force this at all. We don't want to force it. We just want to update. Null reference. What is null here? View frustum's null? How could that possibly be null? Oh. Really? That's just nothing but aggravating. Okay. I get why. This is also why I hate subclasses view frustum. Okay. Well, we'll just make sure it's alive in there. Okay, so here we go. Yeah, so unfortunately, I mean, I had some bugs in my previous session code that surrounding updates. Let's see what I can do here. I wonder how we handle input. Let's see, what can I add? Like window dot on window dot keys. I wonder how you can. I haven't looked, but I figured we could probably figure out how to get keys. I'm not gonna do that right now, but I did want to try. So maybe what we'll do is we'll do main camera. Let's move the main camera. We'll just move the main camera around instead of the cube, but we'll rotate the cube. Right? Makes sense? We good? All right, good. So yeah, so we're moving our camera up and down and we're just rotating the cube. So at this point, we're actually not rotating the cube at all, even though it may look like it. The cube is staying at the origin and spinning, and our camera is moving up and down. And if we wanted to, we could do this. Main camera, look at, and we could pass it the cube and vector 3 unit Y. So we could tell it to look at it. So this time our camera is, you can tell it's moving up and down, but as it's moving up and down, it's continually focused in on the cube as it's rotating. So, okay, so this is good. We have a camera object. We have, we have this detached, we're moving stuff out of here, and we're moving it into physical objects that we can reuse, and as we have this, we're getting this modular approach going. We have a viewport, and we have other things that we're, so like if you notice, like we can start deleting that because we don't have any use for that. And what we're going to end up with, we don't have any use for this anymore either. What we're going to end up with is just this scene stuff. Scene stuff. So, I mean, it's just we're just basically just creating these building blocks. And then once we kind of establish a base set of these objects, then we're going to be able to like say, okay, where do we want to go from now? And then we can create like a chunk and a block type, and actually constructing these voxels and how do they interact together and how they fit together and what do they do and et cetera, et cetera. So the good news is we're making progress. It's very slow, but it's progress nonetheless. Yes, we can get there. Like, you mean like texture, like a texture? We can definitely change the color of the background just by like we can set the color to like whatever. This is gonna be green. Yeah, super ugly. But eventually, what we'll do is we'll create like a Oh, I see what you mean. I see what you mean. Yeah, we can do that. We can do that, and we will do that when we start talking about textures, and we can perhaps do like a cube map or something like that. But absolutely, we can definitely do a cube map. And then that will actually show our kind of relative camera. What we really want to do is add in some WASD support and mouse rotation. So we can follow the mouse just like a 3D first person game where we can just control the camera with our mouse and keyboard. And then that way when we start adding things to our scene, we can start moving and navigating around like by flying around and stuff. And then eventually we can add a physics engine and stuff like that to the background of this thing. Anyway, I got to go. I'm super late for work. But it's been real, guys. Thanks for hanging out, and hopefully we can, we can continue this. We can probably continue tomorrow morning. This one went super long. I don't normally anticipate it to last this long, but 2 hours at the most is probably what I'm going for. It would be nice if I could keep this session to about an hour and a half, but I'm afraid I'm just a little bit too much of a lingerer, and I think 2 hours is doable. This was definitely way past that, so that's going to be my target next time. But anyway, thanks for hanging out, and I'll hopefully see you guys soon. Yes, I do, but I got to look at it later. I got to get to work. I'll talk to you guys later.